Yo, yo, yo! Welcome back. We're doing Math Quest 2012 Math B Chapter 8 review, question 17. Okie dokie. The diagram at right shows part of the curve with the equation y equal to x, e to the power of x over 2. Okay, so that's the curve. Good. Okay, fine. A, the coordinate of point A. Alright, point A is here. Now I know point A has an x coordinate of 2. So, point A has an x coordinate of 2, so there will be 2 and then a y value, right? And the y value is equal to e to the power of x over 2. Okay, well then just sub it in. Sub in 2 as x into y equal to ex over 2 to find y. Right? Logic? Alright, so y is equal to e to the power of x over 2. Y is equal to e to the 2 over 2. Y is equal to e. Alright, 2 over 2 is 1. E to the power of 1 is just e. So, therefore, the point A has a coordinate of, also has not a coordinate, has coordinates of 2 and e. That's right. Alright. Easy. Let's go to the next one. The equation of the normal to the curve at point A. Okay. This was a bit tricky. It says the equation of the normal. Alright. So first we have to find out what is the normal. The normal is a perpendicular line to that particular point. Or well, at point A. It's a perpendicular line at point A, which forms a right angle triangle. So this particular line here. So there's a this straight line has a 90 degree angles. Alright, now to find the equation of normal, or to find any equation, you need three things. And we know that by the look of it, the equation of normal looks like a linear curve, right? So we need three things. We need a y value, we need an x value, and we need a gradient, or we call it of the normal. And now that can be defined as negative reciprocal of the gradient of the tangent, or of the original function. Okay, so we got the y value is e. We got the x value is 2, because we just found out that's the coordinate of point A. Now, the gradient of the normal is what a negative reciprocal of the gradient of the tangent. Now, the gradient of tangent is just the derivative, right? It's just the gradient. The gradient of tangent is the gradient of that function y equal to e to the power of x over 2. So to find the gradient of our y function, all we have to do is just differentiate it. So y is equal to e to the power of x over 2. And y dash is just e to the power of x over 2. This one stays the same. Multiplied by the derivative of that, which is 1 over 2. That gives you e to the power of x over 2 all over 2. Now, we don't want to find, that's the gradient function for the whole curve, but we don't want the whole curve. We want the gradient of the tangent at point A. So at point A, what's our x coordinate? 2. So find y dash when x equal to 2. Y dash equal to e to the 2 over 2 over 2. That is just e over 2. Right? So therefore, the gradient of the normal, this is the gradient of the tangent, right? And therefore the gradient of the normal is equal to negative. So let's swap the 2 and the e. So just 2 over e now. the reciprocal, right? And put a negative sign in front of it. That's it. All right, now you've got the three things you need: an x value and a y value and a gradient of the normal. All right, so let's put it into the to a linear function format. So it's y minus your y value equal to x minus your x value multiplied by m. Yeah, of the normal. Watch out, it is m of the normal. All right, so y minus our y value is e equal to x. Now this y and this x doesn't change. It's not a value. All right, it's just there. Minus x, and x is 2. Right, multiplied by the gradient of the normal. All right, so we can move the e to the other side. Okay, let's expand the bracket. So this is negative 2x over e, right? Plus, because negative is positive, 4 over e, right? Plus e. Yeah? Now, I believe you can just leave it there. You know, a lot of different schools have different format requirement, but if you can express the equation of the normal, y equal to something, 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 that's good enough. All right, I think that's really good enough. So that's our function. Y equal to negative 2x over e plus 4 over e plus e. I'll just leave it like this. So that's question B. The equation of the normal to the curve at point A. Got it. The coordinate of point B. All right. Now the coordinate of point B is on the normal equation. All right. It's part of the straight line. The part of the equation of the normal. All right. And it has a x value of 0. Right. Because it's on the y-axis. So to find, so point B, okay. Point B, right now so far we know is an x value and then a 0. Oh, no, a 0 and then a y value. Because it's on the y-axis. Yeah? And to find y sub x equal to 0 into the normal equation, which is the one that we just got. Yeah, so it's y equal to negative 2x over e plus 4 over e plus e. And now when you sub e, when you sub 0 into x, you just cancel this bit, right? Because you know, multiplied by 0 and then divided by something is always give you the 0. So whatever you left is just, oh, okay, I'll write it just, you know, for the sake of the communication. Alright, so whatever you left, it was just 4 over e plus e. So that's your y value. Alright, so therefore, point B has coordinates of, what's that, x value 0, and the e value is e over 4 over e plus e. There you go. Okay, that's question D done. Question C, sorry. That's question C, sorry. Alright, question D. Find the coordinate of point C. Okay, so C is on the curve of the y equal to e to the power of x over 2. Alright, so that's good. We got the function. And it also have an x coordinate of 0. Right? Because it's also on the, what do you call it? The y-axis. Alright, so point C, so far we know is 0. Sorry guys, my servant, my butler, is taking my jet to maintenance. Sorry for the noises. Alright. Hey, don't laugh. It's true. I have a private jet. Believe it or not. In my heart. Okay, so point C. Alright, so we've got the 0 and a y value. So okay. To find y, sub 0 as x into y equal to e. Yeah, because it's on this function. It's on that point is on this function. All right, so we got y is equal to e to the 0 over 2. That is the same as y is equal to the 0, and that is just 1. Anything to the power of 0 is 1. So therefore, point C has coordinate 0 and 1. That's it. Yeah, 0 and 1. That's done. Point C. Question D done. Excuse me. Answer. Okay. Last one. Point E. So question E. So there's no point E. Okay, the question E. The area bounded by the curve and the line A, B, and BC. The area bounded by the curve and the line A, B, and BC. Okay, so let me rub this thing off. So we're literally looking for these area now. Right? That's alright. It's just area between two curves, right? Between the normal, the equation of the normal, and the y equal to e over e to the power of x over 2 equation. Right? So that is equal to the top one. The normal is the top one. The e to the e to the power of x over 2 is the bottom one. That's fine. And then the coordinates from where to where is from 0, right? X equal to 0 to 0.8. Now the x coordinate of point A is 2. Right? So that's from 0 to 2. Yeah? So far so good? Alright, let's go. Whew. Last question. From 0 to 2, top minus bottom. Integrate with respect to x. So the top function, remember, is our normal function. The normal function is a whole bunch here. It's this one. Negative 2x over e plus 4 over e plus e. Alright. So negative 2x over e plus 4 over e plus as e. Yeah? Minus the bottom function is just e to the power of x over 2. Alright, expand the bracket. Plus 4 over e plus e. And minus e to the x over 2. Integrate with respect to x. Alright. Okay, I mean, you can do some cleaning up or you know, rearrangement to make things easier, but I'm just going to leave it like that and integrate, okay? Being a little bit lazy here. So this becomes this. Alright, easy. Oh, let me write it clearly so you can see what's happened there. So we just took the constant out. So this is e2, negative 2 over e, multiplied by, which is the x, right? And then we integrate the x. So it's become x over 2. Yeah, x squared over 2. Just like that. Alright, so pluses. Now 4 over e is a constant. Alright, e is not an unknown. E is a Euler's number. So there would just be a constant. When you integrate a constant with respect to a variable, you get the constant times that variable. So it's 4 over e multiplied by x. Same as this. Right? Minus. Alright, so this one is e to the power of x over 2. That doesn't change. Divided by the derivative of that, which is 1/2. And that is just, that's it, from 0 to 2. All right, let's tidy things up a bit. So it becomes this, right? And to think the 2 can cancel. So it just becomes, the whole lot just becomes, oh, you can cancel here, you know. So negative x squared over e, yeah, plus 4x over e plus ex minus, now divided by half is just times 2. Alright, so just 2e x over 2 to the power x over 2, 0 over 2. Alright, last bit, suck the fairies in. So this plus 4 times 2 over e plus, well, literally just 2e. Alright, minus 2e to the power of 2 over 2. Minus. Alright, this is gonna be 0. Boom, 0. And that is gonna be 0. Boom, 0. And that is gonna be 0. Boom, 0. But the last one is not. Now, negative 2 times e to the power of 0, that is just 1. Alright, so negative 2 times 1 is negative 2. So that last bit is not a 0. Alright, so it only goes boom, boom, boom. There's no more. Okay. So this one becomes negative 4 over e plus 8 over e plus 2e minus, now that's just 2e. Right? E to the power of 1 is just 1. Okay, so this 2 cancels. Good. Minus negative 2 here. Alright, so that just gives you positive 4 over e. Alright? Minus negative 2, which is plus 2. Because 2 and 4 over e. Unit square. Right, that's your final answer. Whew, that's question 17. Okay, that's a lot of works. Alright, it's literally 20 minutes. Let's head into a commercial break and we come back with the last question of chapter 8 with you, which is question 18.